Hello folks, fellow YouTubers and friends. My name's Raymond Head, and a lot of people call me Boomer. Saying that for any possible new listeners on my channel. Anyway, in this video, what I'm trying to do, number one, I'm not an inventor. I've never once ever invented anything new. However, I have taken other people's ideas and expanded on them and either made them cheaper, easier, or more efficient. So, and I mean, yeah, I'm not trying to brag and say that I did this on my own, no. What I'm trying to say is, if anything is not 100% efficient, there is a room for improvement. Now, main thing I want to discuss about this is the video about turning a ceiling fan into a PMA. There are, I don't know, over 100 anyway, videos on YouTube about how to do this. So I'm not going to bore you with showing you how to do it. I mean, you already know, I've made several videos myself. Number one, in my videos, I don't use the ceiling fan per se. I use a piece of 6-inch Schedule 40 pipe, and I cut it 2 inches. So, and then I turn around and cut the ceiling fan housing down to 1/4 of an inch here, so it goes in. That gives me the double the thickness of the metal here in more diameter, to allow for the magnets. Of course, you take the stator out, and I'm sorry, the rotor. In this case, with the ceiling fan, this is called the rotor, and this is your stator. The stator doesn't move; it's stationary, and the rotor moves because it rotates. Okay, that's why they call it a stator and a rotor. Anyway. In this case, we're not going to throw this away. What we're going to do is we're going to take a hacksaw and cut this here and here. We're going to take these pieces and put them in my lathe and turn them down to where they'll fit between the magnets at these points right here. You can see where the bolts were, and they'll go in, and that'll be my spacer to keep them from getting too tight or too loose. Now, the thing I've done with the ceiling fan PMA, here's the reason for this video, and that's, I want to make that clear. That's why I'm not going into too much detail on actually making the thing, because there's a lot of videos. Some of the best I've ever seen is Muddy Mudman, and if you go to his YouTube site, that's his YouTube ID. If you go to his site and check out his ceiling fan, he has done the ceiling fan PMA rebuild in such great detail that I swear a 12-year-old kid on the short side of a nerd, that's the N word for nerd. Anyway, I had to get that. I saw a comic last night that said that. Anyway. The changing the ceiling fan to a PMA is easy, very easy. The problem is, for what it costs to do it, it's not cost efficient. And the reason for it is not the ceiling fan. In fact, I bought this ceiling fan right here, in a yard sale for $3. I mean, you can find them all day long, every weekend. Somebody's got one in a yard sale for anywhere from $2 to $5. I mean, I've never seen one go for more than $5, unless people were just getting greedy. Anyway, what I want to do is, the reason that the ceiling fan PMA is not cost efficient is the cost of the magnets. And after several years of playing around with these things and other experiments as well, it dawned on me that it is the magnets. I mean, the magnets for PMA, ceiling fan conversion to PMA, runs anywhere from $4 to $6 a piece per magnet. Now, in this case, we have 16 coils. Well, when you multiply 5 times 16, I mean, duh, you're getting on up there into some expense, real expense. However, it comes to my attention, these right here. Oh. These are hard drive magnets. Now, on a hard drive magnet, if you will, look at that really close, that magnet is roughly, is just under 2 inches in length. Now, your coils on your ceiling fan, most of them are roughly 1 inch centers on each coil. So, and the thing is about these magnets, you can buy these for less than $1 a piece on eBay. Depending on how many you buy. If you buy them in quantity, you can get them for way less than $1 a piece. Now, the thing is, these magnets are actually 2 poles on the same side, north and south, or south, north and south, either way. If you put these in, and they're really thin, they're about roughly 1/8 of an inch in thickness. But now, if you take them and put them in a vise and snap them off in dead center, they still maintain the north and south, which all you have to do is break it in the center and flip it over. You have a 1 inch wide by roughly 3/4 inch magnet for $1 that is just as strong as any $5 magnet you would ever buy off of eBay. But like I said, the more of these you buy at one time, the cheaper they are. I got these because I get ridiculous sometimes when I buy things. I bought over 3,500 of them. I paid less than 35 cents a piece, way less. So for 35 cents, I'm going to wind up with a 1/4 inch by 1 inch by 1 inch magnet, which is more than sufficient for the ceiling fan PMA. And at 35 cents times 16, you do the math. That's less than $5 for all the magnets needed for this ceiling fan PMA. Now, like I said, I don't want to make this a long video. I don't want to bore people with stuff that's been done 100 times or more. So what I'm going to do is I'm going to cut this video really short and go ahead and build this thing. Hopefully I can get it built before Wednesday of next week. Well, this coming week. Today is September the 1st, 2018, and it's roughly 4 minutes past 10:30 or 10:34 a.m. in the morning. I always try to give my dates and times so that if anybody watching my video doesn't have to guess how old the video is. Anyway, I'm leaving here in Dallas, Texas on the 5th, which is a Wednesday. I'm going back to Virginia to see my mother. Her birthday is this September the 9th. She will be celebrating her 100th birthday. Wow. I'm really looking forward to that. Okay. Anyway, hopefully I'll get it built before then. I'll show it to you people and so forth. When I get back, what I'm going to do, I'm going to take some of the other ceiling fans that I've done, and I've got a 4 inch by 4 inch pipe going up the side of my shop outside. I'm going to rig up some block and tackle and cabling on that, and to run it with weights and measure the amount of weight it takes to actually drive it, the physical force it takes to drive it. I'll give everybody details on the pulleys, the dimensions of them, number of pulleys there are, number of parts of the line, everything, so that we can figure out how much energy it takes to turn this thing. Once we get the cost of building it down, then we have to know how much energy it takes to turn it to produce electricity. And I'm hoping it'll produce enough usable electricity, where before it's such a small amount. I mean, it's almost nothing to get these things up to 12, 14, 15 volts. I mean, 150 RPMs most of the time will do it. But the amperage is so daggone low by comparison to what the cost of the magnets. That's my whole point. The cost of the magnets, it makes it totally economically unfeasible to even mess with one of these things. Oh, it's nice to light up LEDs and so forth, but I want to be able to build one for less than $10. Therefore, it can sit out and turn in the wind or your waterfall or whatever you've got, and for years. Actually, I mean totally years. We're gonna, once we get it all totally done, we're gonna spray the entire inside with some kind of marine polyurethane so that it can withstand weather outside year after year after year. Most of you people out there have ceiling fans in your house that are 10, 15 years old. So there again, what I'm trying to say is make it economically feasible to take these things and turn them into generators. Now, how cool would it be to have 10 or 15 generators on your property and they didn't cost you $150, but all 10 or 15 of them are sitting around making electricity every time the wind blows? Done. Okay. Enough of that. We're going to have to take these magnets, get them off of here, which in doing so, when you take them off loose, they sometimes, quite often, in peeling them off, the nickel plating peels off. So what we're going to have to do is get a piece of real thin metal, put a piece of wax paper on it, put the magnets down on the wax paper, and then respray with some kind of polyurethane any parts that the nickel plating comes off of. I don't know if how many of you out there have had experience, but when you play with neodymium magnets, if there's any crack or damage at all in the nickel plating, the moisture in the air, the humidity, will actually get inside and cause the magnet to swell and crack almost all of the nickel plating off after a period of time. It takes a while, but it will do it. You have to, once you break them, drill them, or anything like that, any cutting whatsoever through that that nickel plating, it has to be protected. And not all neodymium magnets are nickel plated. Some are gold plated, some are silver plated. Well, nickel's almost silver. It's got a lot in it. But then there's even the ones that are poly coated, you know, with poly resin coated. But anyway, anything to protect them from the weather, from the humidity in the air. So that's the thing. So if anybody wants to try this while I'm out of town on their website, please do so. Because people out here need help. You know, I mean, every one of us has good ideas, and every one of us has bad ideas. And I've put a few of my bad ideas on the internet so that people wouldn't make the same mistakes I did. So, you know, if this is a bad idea and somebody's already tried it, please let me know so I don't waste my time either. But I'm going to give it a shot until somebody tells me that they've tried it. But like I said again, one more time, I'm just trying to figure a way to make it more economically feasible to do it and have fun. That's it. Okay. Well, anyway, I got to get everything ready to go here and take care of my magnets. I got to cut these things off here and put them in the lathe, turn them down, and hopefully I'll get her done before I leave for vacation for my mother's birthday. And when I get back, then I'm going to set up some real, genuine test experiments on it. Okay. By the way, we have not given up on the two-stage oscillator. In fact, we just got over 6 weeks of a wonderful vacation having Jermaine Fishwick from the Netherlands, a little 17-year-old kid that came over and spent 6 weeks with me, and we did a lot of experiments, and we didn't make videos out like a dummy. But anyway, we had fun. But you people have a great time, and I'll see you when I get back. All right, thank you.